Hello, welcome back. All right, we have an easy one, another short one for you. Luckily, just taking a look at my notes here. Make sure I don't miss anything. I should say a few more times, right? That's what you need. So I'm going to show you my screen and show you what I'm looking at here. Ta-da! Orbital period. So what we need to do here is we're going to be taking a look at some objects. We have an array with an object or an array with multiple objects. And each of these objects, they give you a name of this piece of debris that's floating in space away from Earth and its average altitude. Okay, that's average altitude. So the average altitude here and the Hubble, all right, the moon and the average altitude. What do we want? Well, we want the name back and we just want the orbital period as an integer. So that's pretty simple. So we have an object and we want to return a new property of this object called orbital period, spelled just like that. And we want to delete the average altitude. Okay, so it sounds like we're going to be using a for each method for that. Now, granted, you could use a reduce method and generate a new array, but I'm doing exactly what they're asking me here. So I'm just going to add in a new property and delete another one. So let's go ahead. We're bringing in an array of objects. Okay. So ARR. All right. And we're going to be using for each again. And we've done this many, many times before. And our for each takes in an anonymous function. And that function is going to go for each of everything that's inside of this array. And it's an array of objects. So I'm just going to be taking in an object, obviously. And no matter how many objects we send it. And then in that function, give ourselves some space, end our sentence. There we go. We know that at the end, after we go through this for each, we have to remember to turn this array back that we've now modified. Pretty simple, right? All right, so let's start off with deleting a property. So deleting the object property average out avg alt delete object dot average alt. All right, so what happens if we do this? There we go. We just have one key here. That's good. All right, that's half of it. Problem solved. Now, let's take a look at what we need to do. How do we transform an average altitude into an orbital period? Here's the Wikipedia link they send you. All right, and it explains everything that we need to do. And if you notice here, this is what we're doing, is we need to take the average altitude or the semi-major axis. All right, the semi-major axis of is here and here, okay? And you're kind of looking at this. That's fine. It's all good. Well, what this all basically boils down to, we have two bodies essentially orbiting each other. And so this is the equation we need. Once you figure out this is the equation you need, it becomes very, very easy. How do I know that's the equation we need? Well, honestly, I just looked at these. I was like, which one of these things look like it? So it's either going to be this one, or it was going to be this one. How do I know that? Well, take a look. They give us a g times an m already, and they give us an Earth radius. And then we have something orbiting the Earth. So that makes sense. So something is going to be orbiting above the Earth's surface, and then we're going to have to use the Earth's orbit as well to calculate this. So which one of these things is an Earth's orbit plus another orbit? All right. Oh, look, it makes sense. Look, equal to their constant separation for circular orbits. Oh, that sounds like it's exactly what we want. And again, just take some reading. All right, so that's what we want. If you really want to see, look, this one is t in seconds, and we didn't get seconds or anything like that. This little p here, we didn't get anything for that. This one just has a pi. All right, a g times an m. All right, the m is the sum of the two masses. It looks like the gm for Earth are giving us very small things, so that second mass is probably going to be negligible. So that g times m they gave us. All right, so just by looking at what they gave us and what they want, this is most likely the equation that we need. That a looks like we're going to have to calculate that a with this Earth radius, but we're also given that orbital period, remember? So we're probably going to have to use both of those. And if we take the Earth's radius itself, which is the distance from the Earth to the center point, plus how far away this thing is flying away, like Sputnik or the space station. We're probably going to have to add those together to get our A that we're going to have to use. So it means a to the third, so we're going to need math.power. Power, we're going to have a base component and then the exponent, all right, just like in your math classes there. So here we go. This is all we're doing. It's something very simple. So 7 squared, 7 cubed, 2 to the 10th. We're going to do A, which is going to be our orbital period that we're going to calculate with these two radiuses, which is the radius of the Earth plus whatever the radius is that we're adding onto that for the height that it's flying above the Earth. All right, and then we're going to be taking the math.power. Something else you got to remember here is we need to create something else here, a new property called orbital period, right? So I need to take this object, and I need to create orbital period and make sure it's spelled just like they want down here, right? And the orbital period, we need to set that equal to something before we delete the average altitude. And we're going to be using this average altitude as well. The first thing you should notice here is that this is an integer. So we're going to have to use this math.round, which generates an integer, and we've used this before. Math.round, and all of our math is going to go in our math.round. All right, so let's go in here. 2 pi times the square root of something, right? So how do we do 2 pi? Well, luckily there's 2 times, all right, math.pi, right? So math.pi, all right, so you can kind of search for that. That's just something that I kind of looked up right there. It's pretty simple if you want to know how to do math.pi. Okay. There you go. Math.pi. Ta-da. And it gives you pi. So that we don't have to worry about it since there's no pi symbol on my keyboard anyway that it's going to understand. And we need the square root, all right? So we need to multiply that by square root. And again, we can use math.square root. Square root, again, it's built in. Okay, so let's keep these things straight. So we have math.square root, not math square root, math.square root. Right. And we need to go into the power, okay? And again, we're just using math functions here. It's all we're really doing. Math.power, which I showed you earlier. Math.power takes in 2 things, something, comma, something else. All right, this is going to be, all right, to the cubed root. And again, this is just order of operations. All right, so think back to your math classes and order of operations. That's all we're doing. All right, so we need to multiply 2 times pi times the square root, right? 2 times pi times square root of what's in, this is all underneath the square root. And we're going to be taking the math.power. So again, we're doing the top of this, and then we're going to divide it by something else. Just simple order of operations. All right. Now, the first thing of this that we need to bring, that A, we need to define that A. And that A is just going to be the Earth radius, right? And we have to add that to our average altitude for each object. Object dot avg alt. Right? So we're going to be doing the math with this before we delete it. Okay. And now that we have the power of 3, that's this, and we have to divide it by this gm. Okay, so right after we're done with the square root, we divide that first. So right when we're done with the cube, we're taking that to the cube power rather, we need to divide this by the gm, which is provided to us. Okay. So all I did was I made an orbital period equal to this math, and this math is just this with the variables they gave us. Oh, there you go. They're in another castle. Ta-da! You get name, all right, key value, key orbital period, and a value. And if you want to test this with multiple other objects, you should get the same thing as well. A side note on this, again, I'm modifying these objects themselves, okay, using the for each. If you wanted to generate a new array, you could use a reduce and push this stuff to a new array. But again, it's really just asking us to just modify the objects themselves. I think both of those solutions will pass, though. So again, hopefully this one was helpful, and I'll see you again next time.